Diamond.
Ooh.
Ow! Welcome to my tech farm. E3D sent me DiamondBack hotends for the testing. I got these boxes for free, but there is no additional payment from their side. But this video and the whole channel is sponsored by Polymaker. These hotends are available for several printers. These are for the BambuLab H2, P2S, X2D printers. These are extremely wear resistant nozzles, and their hardness is much higher even compared to the steel, tungsten or even ruby nozzle. And on the other side, their thermal conductivity is also much higher compared to many other materials. These are engineered for smoother top layers, sharp details. And I'm not sure how to check this. Maybe I will analyze some printings under the microscope to see if we can notice some difference or not. Exceptional thermal conductivity, which improves the layer adhesion, and definitely this is something I will test in this video. And these hotends are rated up to 350 degrees Celsius according to E3D. These are not high flow nozzles and they will be compared with the standard BambuLab nozzle. On the other side, these have better thermal conductivity, so we should see better performance using the same settings. Let's see what's in the box. This is 0.4 and 0.6 mm diameter. There is a very important warning on the top. For the multi-nozzle systems like H2D, disable preprint nozzle offset calibration in Bambu Studio and perform high precision nozzle offset calibration on the printer. Reason for this is that automatic nozzle offset calibration in Bambu can become unreliable with the DiamondBack nozzles because the tip is not standard conductive metal and has different contact behavior. So you should disable this when sending the print to the machine. Instead, go to Settings, Calibration, High Precision Nozzle Offset Calibration, and this method uses printed lines for alignment, requires dark and light PLA filament, and determines the offset visually optically instead of relying on the contact sensing. In my case, I will use P2S, but I think this was important to mention if somebody wants to use this hotend on H2D printers. Scan for instructions, and same warning here. This is the back side, aligning surface for the heat transfer. These are magnets. Front side we have a QR code, and then we have the information about the nozzle, and this is 0.4 and 0.6 millimeters. And small advantage of standard nozzles compared to high flow CHT-like nozzle is a small risk of clog, especially if we print with those carbon fiber filaments. I'm starting with 0.4 mm standard nozzle, and the material I will use is carbon fiber reinforced PETG by Tinmori. And these are my test objects for the layer adhesion, generic PETG CF settings. Of course I will modify them a little bit, 70 on the bed and 270 will be on the nozzle temperature. And the maximal flow I increased to 16 because this is the max flow test. The cooling between 5 and 40%. And I have this owl because I don't want a reduction in the speed because of the minimal layer printing time. So as you can see, it will keep this speed and the flow even on that smaller cross-section area. Similar settings for the 0.6 mm nozzle. Here you can see a few seconds of the printing. I dried the filament, but now the filament dryer is opened. Bed adhesion check to see if I need to increase the temperature. Yes, maybe a little bit. For preparing the max flow test, I'm using Orca Slicer from 10 to 50, step 0.82. With this height of this object is exactly 50 millimeters, and from distance from the bottom I can calculate the maximal flow. It's really rare to see the spool rotating so fast. It will be finished in 1 minute. I definitely don't like this high flow, but I will leave it to be finished. Now we have something for comparison. It's time to replace the nozzle, removing the standard 0.4 and inserting the DiamondBack version. On P2S this is very easy to do. I can do it basically with one hand. And I'm using the same G-code here. DiamondBack nozzle, using the same file. And from here it looks very similar like with the previous nozzle printing. But I will analyze it later. On the max flow test, very similar behavior, but I will analyze them later side by side. What a mess. One more nozzle change, moving to 0.6 mm. I'm starting with the standard version. And important to inform the printer about this change. This printing looks slower, but because of bigger diameter and bigger layer height, the flow rate is the same. Of course, these two walls are stronger and this layer adhesion will be bigger compared to previous printing with 0.4 mm nozzle. The printing will be finished in 7 minutes, and so far this one looks better than 0.4 mm nozzle. It's finished. And one last change for this video, from standard to DiamondBack 0.6 mm. And the last group. Now it started with the visible under extrusion, 7 more minutes of printing. Similar problems like with the previous one, but it's finished. Let's analyze first the print quality. Standard nozzle and DiamondBack nozzle, these are printed with 0.6 mm, and really visually I cannot see any difference between these two objects. And these are printed with the 0.4 mm nozzle, also visually absolutely no difference between them. Now there is still one thing I noticed. So this is the standard nozzle and this DiamondBack nozzle. And I noticed some minimal difference on the top surface. It is really hard to tell. I will try to use it under some angle to see the light reflection. But this one printed with DiamondBack nozzle is a little bit smoother. But as I mentioned, it is extremely hard to notice the difference. Maybe this difference would be bigger if there are some old nozzle, because this standard nozzle is relatively new. And probably by time it will wear out more quickly. And in that case, the DiamondBack nozzle would be even better. Now let's analyze the maximal flow. Standard nozzle, DiamondBack nozzle, 0.6 and 0.4 mm. And what we can see that on the top, on the maximal flow in this test, the DiamondBack nozzle failed earlier. But I wouldn't worry about this because we don't want to print anyway, not even near this flow rate. What is more important, when it started with the visual under extrusion, and actually that's very similar, or maybe even better with the DiamondBack nozzle. 0.6 mm DiamondBack standard nozzle, 29-28 mm. Later I will show you what that means in the flow rate. 0.4 mm DiamondBack and standard nozzle, and around 17 mm in both cases from the bottom. Let's measure that layer adhesion. 0.4 standard nozzle, 0.4 DiamondBack, very similar, 0.6 standard, 0.6 DiamondBack, a little bit weaker. With 0.4 mm nozzle, the strength or break load was very similar. Now printing with 0.6 mm, we can see some small advantage when printed with standard nozzle compared to DiamondBack. Before conclusions, just few words mostly to new viewers. Usually at the beginning of the video, I will provide some specifications about some product given by the manufacturer. Then I will do some testing, and at the end of the video in the conclusions part, I will just provide you the facts. And during all this, you will not see ads during the video. About the price. Well, these DiamondBack nozzles are expensive, definitely, no question about this, compared to standard hotends. About the maximal flow, I couldn't measure any significant difference between these two hotend types. Now with the layer adhesion, with 0.4 mm nozzle, the difference was basically zero. Now with 0.6 mm, I could measure some advantage when printed with the standard hotend compared to DiamondBack, The difference was approximately 10%. Is it significant or not? Decide yourself. About surface quality. I couldn't visually see any difference when printed some figures. I noticed some difference, advantage on the DiamondBack hotend when printed on some horizontal surfaces. Those was a little bit shinier. The difference was extremely hardly noticeable, even with bare eyes. Probably you didn't even notice over the camera. But I think that this difference would be even bigger if this would be some old hotends, because this is the main advantage of the DiamondBack hotend, the lifespan. And I think that it will keep the same quality even after 2 or 3 years of printing, especially if you are printing a lot with carbon fiber or similar abrasive filaments. Compared to standard hardened steel nozzle, yes, it is hardened steel, but the DiamondBack is much harder and its lifespan is much longer. So I think this is the main advantage of this hotend. Is it worth that price difference? Well, this is something what you have to decide yourself. Okay, this was my experience with the DiamondBack hotends. Huge thanks to Polymaker for supporting my channel, and to all my Patreon supporters, and to all you others. But thank you for watching this video out in the end, and as always, happy printing!